Okay, so here is my first video lesson that I've ever done for this class. And what we're going to do is take a look at the chemical equation that we did in our lab. We began on Thursday, we collected our data on Friday, and it was a double replacement reaction. And our reactants were Ki, which is potassium iodide, plus lead 2 nitrate, which is written out like this. Now we have to do quite a few things for the lab. The first thing we need to do is we need to find out what the reactants for this particular reaction would be. And what we should notice is that this is a double replacement reaction, and we're dealing with two ionic compounds here. We know in a double replacement reaction what's going to happen is our partners are going to switch up here. The metal from one is going to attach itself to the nonmetal or the polyatomic ion in this case of the other, and vice versa. So let's first, before we do anything else, let's break down these ionic compounds into what their constituent ions would be. So when we put the potassium iodide solution into water to create the solution, the potassium dissociated to form potassium ions, which had a charge of +1, and iodide ions that had a charge of -1. When we put the lead nitrate into the water solution, it dissociated, and the lead became, because we know it's lead 2, it became a +2 ion. And the nitrate, the polyatomic ion, we could check that by looking at our periodic table. We could see that has a charge of a -1. So now we have to figure out what new ionic compounds are going to be forming. So we could identify that the potassium is going to partner up with the nitrate. So we write the K positive, we write the NO3 negative, and then determine our subscripts. We do our crisscross applesauce to find out how many of each one we need. We need one of each, so the potassium and the nitrate are going to form KNO3, which is potassium nitrate, a very common compound that's found in things like fertilizer and gunpowder. But fortunately for us, it is not too caustic, and it's something that we could pour right down the sink when we're done. We also would form our precipitate. In this case, it's going to be the combination of the lead and the iodine. So let's put them next to each other. We have our lead, which is going to be a +2 ion, and we have the iodine, which is a -1. And crisscross applesauce, we know that the potassium iodide is going to have the chemical formula of PbI2. So that is what our precipitate, that is what that beautiful yellow substance that you collected, that's what we measured. This is our precipitate. The KNO3 was soluble, so it never became a solid. And if we take a look at table F, we'll see that while most halides do form compounds that are soluble, one of the exceptions is it when it's forming with this lead 2 ion. So that is what the chemical equation will look like. However, this is not a balanced equation. So to balance this, we have to figure out what we have in our reactants and what we have in our products and figure out how we could balance it. We need to make sure that we balance it, or else we cannot do our mass-to-mass ratio that we're going to need to do to answer questions in the lab. So looking at what elements we have present, we have potassium, we have iodide, we have lead, and we have NO3, we have nitrate, and let's keep that together. We're going to use that one ion, that polyatomic ion, we're going to keep it together because we could do it that way in terms of the balancing. So taking a look at both sides, we have one potassium in our reactants, one in our products. We have one iodide in our reactants, but here we could see the subscript 2, we have two iodides. We have one lead, and we have two NO3s here, two nitrates, and only one over here. So we have to do some balancing. So taking a look at this quickly, I will see that I need to balance my iodides. And I could do that by putting a 2 here. Now that I have a 2 there, I multiply my iodides by 2, which gives me 2. But I put that coefficient in front of the K as well, so I multiply that. So I have 2. That's great for my iodides, but now my potassiums and my nitrates are not balanced, so I put a 2 here, multiply that by 2, and I multiply this by 2 equals 2 equals 2, and I could see that I am completely balanced. So what this represents here now is our balanced chemical equation. 2 potassium iodides plus 1 lead nitrate yields or gives us 2 KNO3 plus 1 PbI2. So this is how you would find out what your reactants are and how to balance the equation for your lab problem. I hope this helps, and good luck with the rest of your lab. You'll use this information now to go ahead and answer the rest of the questions and do the calculations. Good luck.